The Sun, a blazing ball of plasma that dominates our sky. This celestial giant is the anchor of our solar system, holding planets, asteroids, and comets in its gravitational embrace. Without the Sun's energy, our planet would be a frozen, lifeless wasteland. Life as we know it wouldn't exist. The Sun's influence extends far beyond its visible surface. Its immense gravity dictates the orbits of all objects in the solar system. Even the faintest glimmer of sunlight reaching distant planets provides a source of energy and warmth. The Sun is a life giver, a source of wonder, and a constant presence in our cosmic neighborhood. Our understanding of the Sun has evolved over millennia. Ancient civilizations revered the Sun as a god, recognizing its vital role in their lives. Today, we explore the Sun with sophisticated telescopes and spacecraft, unraveling its secrets and gaining a deeper appreciation for its power. The Sun may appear as a smooth, glowing orb, but it is a dynamic and complex structure, constantly changing and evolving. Its surface is a seething mass of energy and activity, with solar flares and sunspots appearing and disappearing. At its core lies a nuclear furnace where hydrogen atoms fuse to form helium. This fusion process is the heart of the Sun's power, driving its immense energy output. This process, known as nuclear fusion, releases an incredible amount of energy. The energy produced in the core is so vast that it powers the entire Sun, providing the light and heat that reach Earth. It is this energy that powers the Sun and radiates outward into space. The energy travels through the various layers of the Sun before it finally escapes into the solar system. Surrounding the core is the radiative zone. Here, energy from the core slowly makes its way outward, constantly interacting with particles. This journey can take thousands of years as the energy bounces from particle to particle. The next layer, the convective zone, is a chaotic region where hot plasma rises and cooler plasma sinks, much like boiling water in a pot. This movement helps to transport energy to the Sun's surface. The visible surface of the Sun is called the photosphere. This is the layer we see from Earth, and it is where sunlight is emitted. The photosphere is marked by granules, which are the tops of convective cells. Above the photosphere lies the chromosphere, a thin layer visible during a solar eclipse as a reddish rim. This layer is hotter than the photosphere and is where solar prominences and spicules are found. Extending far into space is the outermost layer, the corona, a superheated region of plasma only visible during a total solar eclipse. The corona is incredibly hot, much hotter than the surface of the Sun, and it extends millions of kilometers into space, influencing the solar wind and space weather. The Sun is not a static object. It is a dynamic and ever-changing star. One of the most dramatic manifestations of the Sun's activity are solar flares. These are sudden bursts of energy and radiation that erupt from the Sun's surface. Solar flares can disrupt communications on Earth and even pose a risk to astronauts. Another intriguing feature of the Sun is sunspots. These are cooler, darker regions on the Sun's surface that are caused by intense magnetic activity. Sunspots often appear in groups and can last for days or even weeks. The number of sunspots on the Sun's surface varies over an 11-year cycle, known as the solar cycle. Understanding the Sun's activity is crucial for protecting our technological infrastructure. Scientists constantly monitor the Sun for signs of solar flares and other space weather events. By studying the Sun's behavior, we can better prepare for potential impacts on our planet. Section 4. A star's life story from birth to red giant. The Sun, like all stars, has a finite lifespan. It is a journey that spans billions of years, filled with dramatic changes and transformations. It was born from a collapsing cloud of gas and dust about 4.6 billion years ago. This process is known as stellar formation, a common phenomenon in the universe. This cloud, known as a nebula, contracted under its own gravity, eventually igniting nuclear fusion in its core. This fusion process is what powers the star, producing light and heat. The Sun is currently in its main sequence stage, where it will spend billions of years steadily fusing hydrogen into helium. This stage is the longest and most stable period in a star's life. However, as the Sun ages, it will gradually run out of hydrogen fuel in its core. This depletion marks the beginning of the end for the Sun's main sequence phase. This will cause the core to contract and heat up, eventually triggering the fusion of helium into heavier elements. This phase is known as the red giant phase. As the Sun evolves, it will expand significantly, becoming a red giant star. Its outer layers will swell, and its color will change to a deep red. This expansion will engulf the inner planets, including Earth. The intense heat and radiation will make life on our planet impossible. Eventually, the sun will shed its outer layers, leaving behind a dense core known as a white dwarf. This remnant will be incredibly hot and dense. This white dwarf will slowly cool over trillions of years, eventually fading into a black dwarf. This final stage marks the end of the sun's life cycle, a silent and dark conclusion to its brilliant existence. Section 5. The sun's enduring legacy. The sun is more than just a star. It is a colossal sphere of burning plasma, a beacon of light and energy that has shaped the very fabric of our existence. It is the source of life on our planet and a constant presence in our sky. Its rays nourish the plants, warm our oceans, and drive the weather systems that sustain life. From the ancient civilizations that worshipped it to the scientists who study it today, the sun has captivated humanity for millennia. Its influence is evident in our myths, our calendars, and our scientific endeavors. As we continue to explore the cosmos, the sun serves as a reminder of our place in the universe. It is a touchstone, a familiar presence in the vast expanse of space. It is a humble star, one of billions in our galaxy, but it is our star. Its gravitational pull keeps our solar system in balance, and its light is a constant in our lives. The sun's energy sustains us, its light guides us, and its story reminds us of the vastness and wonder of the universe we inhabit. Its cycles influence our days, our seasons, and our very existence. Even billions of years from now, long after the sun has reached the end of its life, its legacy will live on. Its transformation into a red giant and eventual collapse will be a testament to the life cycle of stars. The elements forged in its core will be scattered throughout the cosmos, seeding the formation of new stars and planets. These elements are the building blocks of life, spreading the sun's legacy far and wide. And perhaps, on one of those distant worlds, life will emerge once more, bathed in the warm glow of a star born from the ashes of our own sun. The cycle of life and death, creation and destruction will continue, echoing the enduring legacy of our sun. Section 6. The sun's influence on Earth. The sun is not just a distant star, it is the lifeblood of our planet. Its energy reaches us in the form of sunlight, a crucial component for photosynthesis, the process that allows plants to convert light into food. This simple yet profound process forms the foundation of Earth's food chain. Beyond the biological realm, the sun's energy drives Earth's weather systems. The heat from the sun warms the Earth's surface, causing air to rise and create wind patterns. These patterns, in turn, shape our climate and weather, influencing everything from ocean currents to rainfall distribution. The sun also plays a pivotal role in Earth's seasons. As our planet orbits the sun, the tilt of its axis causes different parts of the Earth to receive varying amounts of sunlight throughout the year. This axial tilt gives rise to the changing seasons, influencing agriculture, ecosystems, and even human cultures. But the sun's influence extends beyond the physical. Throughout history, cultures around the world have revered the sun, incorporating it into their myths, legends, and rituals. From the ancient Egyptians who worshipped Ra, the sun god, to the Aztecs who believed the sun needed human sacrifices to rise each day, the sun has been a central figure in human spirituality and mythology. In modern times, the sun continues to inspire awe and curiosity. Scientists study solar activity to understand its impact on space weather, which can affect satellite communications and power grids on Earth. Solar energy, harnessed through technology, offers a sustainable solution for our growing energy needs. As we gaze up at the sun, we are reminded of its profound influence on our planet and our lives. It is a source of life, a driver of weather, and a symbol of enduring power. The sun's energy touches every aspect of our existence, from the food we eat to the technology we rely on. In every sunrise and sunset, we see the sun's daily dance, a reminder of the intricate balance that sustains life on Earth. As we continue to explore and understand our universe, the sun remains a constant, guiding us with its light and energy. The sun's influence on Earth is a testament to the delicate interplay between celestial bodies and the life they nurture. It is a relationship that has shaped our past, defines our present, and will continue to influence our future. As we look to the stars, we carry with us the knowledge that our sun, and all its brilliance, is a beacon of life and a reminder of the interconnectedness of our universe. Section 7. Solar eclipses and phenomena. Among the most awe-inspiring events in our sky are solar eclipses. These rare occurrences captivate observers worldwide as the moon passes between the Earth and the sun, casting a shadow and momentarily obscuring the sun's light. During a total solar eclipse, the day turns to night, temperatures drop, and the sun's corona becomes visible, revealing a halo of plasma that extends millions of kilometers into space. This phenomenon offers scientists a unique opportunity to study the sun's outer atmosphere and gather data that is otherwise difficult to obtain. Partial and annular eclipses, though not as dramatic as total eclipses, still provide a spectacle. In an annular eclipse, the moon's apparent size is smaller than the sun, creating a ring of fire effect. These events remind us of the precise and beautiful mechanics of our solar system. Beyond eclipses, the sun also presents other phenomena, such as sunspots and solar flares. Sunspots are cooler, darker areas on the sun's surface, often associated with intense magnetic activity. Solar flares, on the other hand, are sudden eruptions of energy that can affect space weather and even disrupt communications on Earth. The sun's magnetic field also gives rise to the mesmerizing auroras, known as the northern and southern lights. These natural light displays occur when charged particles from the sun interact with Earth's atmosphere, creating vibrant, dancing lights in the polar regions. As we continue to study these phenomena, we gain a deeper understanding of the sun's complex behavior and its impact on our solar system. Each solar event, from eclipses to flares, offers a glimpse into the dynamic nature of our closest star. In the grand tapestry of the cosmos, these solar phenomena are threads that weave together our understanding of the universe. They remind us of the sun's powerful presence and the intricate dance of celestial bodies that shape our world. As we marvel at these events, we are reminded of our place in the universe and the enduring legacy of the sun. As we look to the future, the quest to understand the sun continues to drive scientific innovation and exploration. New missions such as NASA's Parker Solar Probe and the European Space Agency's Solar Orbiter are designed to get closer to the sun than ever before, capturing unprecedented data about its atmosphere and magnetic fields. These spacecraft are equipped with advanced instruments that can withstand extreme temperatures and radiation, allowing us to study the sun's corona and solar wind in detail. The insights gained from these missions will help us predict solar storms and protect vital technologies on Earth. We are also developing solar telescopes with higher resolution, enabling us to observe the sun's surface with unparalleled clarity. These advancements will deepen our understanding of solar activity and its impact on space weather. In the coming decades, international collaborations will be key to unlocking the sun's secrets. By pooling resources and expertise, we can achieve breakthroughs that were once thought impossible. As we push the boundaries of solar exploration, we are not just unraveling the mysteries of our closest star. We are paving the way for a future where humanity can thrive in space. The sun, our life-giving star, holds the key to understanding the universe and our place within it. Throughout history, the sun has been a source of inspiration, reverence, and mythology for cultures around the world. In ancient Egypt, the sun was worshipped as the god Ra, the ruler of all creation. Ra was believed to travel across the sky in a solar boat, bringing light and life to the world. In Greek mythology, the sun was personified as Helios, who rode his chariot across the sky each day. His daily journey was a symbol of consistency and order in the universe. The Aztecs believed the sun was a warrior who fought darkness each night to rise anew each morning. They performed rituals and sacrifices to ensure the sun's daily victory. In Hindu culture, the sun is revered as Surya, a deity who drives away darkness and ignorance. Surya is often depicted riding a chariot pulled by 7 horses, representing the days of the week. The sun also plays a vital role in the spiritual practices of Native American tribes. The sun dance, a ceremonial ritual, is performed to honor the sun and seek its blessings. In modern times, the sun continues to inspire art, literature, and music, symbolizing hope, renewal, and the passage of time. These cultural narratives remind us of the profound connection between humanity and our radiant star. As we advance in our scientific understanding, we continue to be awed by the sun's enduring presence in our lives and its timeless influence on our world. The sun, both a scientific marvel and a cultural icon, remains a central figure in the story of human civilization. The sun is not only a source of light and life, but also a key player in Earth's climate system. Solar radiation drives weather patterns, ocean currents, and the distribution of ecosystems. When solar energy reaches Earth, it warms the planet's surface, causing air and water to circulate. The sun's activity, including solar flares and sunspots, can influence climate over short and long periods. During periods of high solar activity, increased solar radiation can lead to warmer temperatures. Conversely, low solar activity can contribute to cooler conditions, as seen during the Little Ice Age from the 14th to 19th centuries. Human activities, such as burning fossil fuels, also impact the climate, but the sun's influence remains a critical factor. Understanding the interplay between solar activity and human-induced climate change is essential for accurate climate models. As we continue to study the sun and its effects on our planet, we gain valuable insights into the complex dynamics of Earth's climate system. These insights help us predict future climate scenarios and develop strategies to mitigate climate change. The sun, our ever-present star, continues to shape the environment in which we live. The sun's magnetic field is a powerful and dynamic force that extends far beyond its surface. Generated by the movement of electrically charged particles within the sun, this magnetic field shapes the solar wind and influences the entire solar system. The magnetic field is responsible for the creation of sunspots, which are cooler, darker regions on the sun's surface. These sunspots follow an 11-year cycle known as the solar cycle, during which the sun's magnetic activity increases and decreases. During periods of high magnetic activity, the sun can release vast amounts of energy in the form of solar flares and coronal mass ejections. These events can have significant impacts on space weather, affecting satellite communications and power grids on Earth. The sun's magnetic field also creates the beautiful auroras seen near Earth's poles, as charged particles interact with our planet's atmosphere. Scientists continue to study the sun's magnetic field to better understand its behavior and predict its effects on our technology and daily lives. By unraveling the mysteries of the sun's magnetic field, we gain deeper insights into the workings of our star and its influence on the cosmos. The sun's magnetic field is a testament to the intricate and powerful forces that govern our universe. The sun's impact on technology is profound and far-reaching. Modern technology relies heavily on satellite communications, navigation systems, and power grids, all of which can be affected by solar activity. Solar flares and coronal mass ejections can disrupt radio signals and damage satellites, leading to communication blackouts and navigation errors. Power grids on Earth are also vulnerable to geomagnetic storms caused by the sun's energetic particles. These storms can induce electrical currents in power lines, potentially causing widespread outages. To mitigate these risks, scientists and engineers monitor the sun's activity and develop technologies to protect our infrastructure. Space weather forecasting helps predict solar events and allows for preventive measures to be taken. Understanding the sun's behavior is crucial for the continued advancement and reliability of our technological systems. As we become more dependent on technology, the sun's influence on our daily lives becomes increasingly significant. By studying the sun's impact on technology, we can better prepare for and adapt to the challenges posed by our dynamic star.